All right, class, as we continue our discussion of partial fractions, here is another example, another type of partial fraction that you might come across. The fundamental theorem of algebra says that any polynomial can be factored into linear or quadratic terms that won't factor. And so we should be able to factor our any denominator that you have into terms that are like an x minus 4, that's a nice linear factor, or you might get in a factor with an x squared in it, like x squared plus 1. X squared plus 1 is a factor that you can't break down any farther. X squared plus 1, you can't break it down without getting into imaginary numbers, and we are not ready to do calculus with imaginary numbers yet. That was a course I did in graduate school. But so the way that we set this up here is we take the antiderivative of, we set it up as an ax plus b over the x squared plus 1. That quadratic term, you're going to have an x on top as well in order to get things to work out to the point where we can do antiderivatives the way we want them to. So I want an ax plus b over the x squared plus 1, and just a plain old c over that linear factor over the x minus 4. And like before, we're going to start by getting a common denominator. And to get that common denominator, I'm going to multiply the ax plus b times an x minus 4. And I'm going to multiply the c by an x squared plus 1 in order to make those denominators the same. All right? And now I need to find out what a, b, and c are. And again, the quick way is these two should be true for all single values, all values of x. And so any value of x you choose should make them the same for these two polynomials. And so I'm looking at that x minus 4 and thinking, well, if x is equal to 4, some really nice things are going to happen. On the left-hand side, I'm going to get 6 times 4 squared minus 7 times 4 plus 17. Maybe that's not so nice, but the ax plus b is going to get multiplied by 0 here. And I love multiplying by 0. And then you're going to do c times 4 squared plus 1. You're going to put in x is equal to 4 all the way across. The nice thing is that ax plus b term fact cancels out. And let's see, I'm going to have 6 times 16 minus 28 plus 17 is equal to c times 17. And 6 times 16. I'm going to pause here a little bit and grab my calculator. I left it off. So instant entertainment here. I'm going to disappear and I'll be right back with an answer. Okay. The 6 times 16 minus 28 plus 17 all works out to be 85. So 85, come back pin, 85 is equal to c times 17. So c is equal to 5. That's one piece I need. I need to find the other values here. Let's see, I need to pick another good easy value to use for x. Plugging in 0, I've always been good at plugging in 0. So if x is equal to 0, the right hand side is just going to be 17. The left hand side, the left hand side is 17. The right hand side would be b times negative 4 plus c times 1. But I already know c is equal to 5. So I'll have 17 is equal to negative 4b plus 5. And if you subtract 5 from both sides of that equation, I'll get 12 is equal to negative 4b, and b is equal to negative 3. It's so nice that these are all working out to whole numbers. Unfortunately, in real life, that doesn't always happen, but that way we're not getting caught up in the arithmetic. We can focus on the math. All right, now I need to find a. I know what b and c are. I need to find a. Let's try x equals 1. That's generally a pretty easy number to plug in. I'll have 6 minus 7 plus 17 on the left-hand side. On the right-hand side, I'll have a times 1, or a plus b, a plus negative 3, times 1 minus 4 plus c, whoops, well c is 5, let me just turn that c into a 5, times 1 squared plus 1. So that's going to give me 10, 16 is equal to a plus a minus 3 times a negative 3 plus 5 times 2. 16 is going to equal negative 3a plus 9 plus 10. So if I move everything to the other side over here, the 9 and the 10, subtract them from the 16, I'll get a negative 3 is equal to minus 3a. So a is equal to 1. So now my antiderivative that I was working on before, the antiderivative of, where does it go, 6x squared minus 7x minus 17 over x squared plus 1 times an x minus 4 dx is the same as the antiderivative of 1 times x. It was ax plus b, and b I think was negative 3, all over the x squared plus 1 plus c over the x minus 4 term. And I'm going to split that up into two separate integrals. Let me run up here real quick and double check, make sure I got those in the right spots. Yeah, it was ax plus b and then c over the x minus 4. Gotta make sure we're putting those in the right spots. Okay, so how easy are these to do in terms of antiderivatives? Let's see, I think I can do well, I can split up that first one. I gotta split it up once more. X over x squared plus 1 minus 3 over x squared plus 1 dx plus the antiderivative of 5 over x minus 4 dx. Alright, this very first integral here, I'm going to do a little bit of substitution on that very first term. I'm going to say u is equal to x squared plus 1, and then du is equal to 2x dx. And so to do that first integral, I need a 2x dx, so I need a 2x, but if I can't just add in a 2, I got to add a 2 down there, times u du, well the 2x, that's going to become part of my dx, so that's just going to become a 1 there. Let me just clean that up. Alright, so I should have a 1 over u, 1 over 2u du, or 1/2 du. To get the x by itself, I need a 1/2 du, so I'm going to add an extra du, minus the antiderivative of 3 over x squared plus 1 dx, plus the antiderivative of 5 over x minus 4 dx. And I think I can do each piece now. The antiderivative of 1 over u is just the natural log of u. So I'm going to get 1/2 times the natural log of u, but u was this x squared minus 1, or x squared plus 1. So I'm going to get 1/2 the natural log of x squared plus 1. This next one, I'm looking at it as 1 over x squared plus 1. Well, that one, there was something that's derivative was 1 over x squared plus 1, and that was the arctangent. The arctangent, the derivative of the arctangent of x is 1 over x squared plus 1. That's the one that I'm always, well, it's kind of like this 1 over u, that the antiderivative is the natural log. The 1 over the x squared plus 1, its antiderivative was the arctangent, or the inverse tangent. And that might be something you're going to have to reach back quite a bit to remember from your pre-calculus, or from your Math 151 days. But it's true. The antiderivative of 1 over x squared plus 1, or the derivative of arctangent, was 1 over x squared plus 1. So that's a useful thing to remember there. All right, and then here I'm going to get another natural log of x minus 4, and then plus c at the end. And so there is our antiderivative. A little bit more painful because if we have that, you got to remember that the antiderivative of 1 over x squared plus 1 is the arctangent, but certainly something we can find the antiderivative of. So let's go with that.